So the supposition is that f is some sort of differential function. It may be a function of two variables or three or even more. We want to know what is the maximum value. So we're going to say that then the maximum value of the directional so the maximum value of the directional derivative du of f of x is given by the magnitude of the gradient vector, if you recall, like so. And it's not like, it is the magnitude. And it occurs when u has the same direction as the gradient. There was a question? Okay. That word is value. The u, yeah. Well, that was for Monday. Right. So I'll put the u of x, and I need to f of x, and I need to put a vector on top of it. Okay, and let me do it again here, and let me do it again here, and here I need to add where x is really the vector x, y, z, like so. So, and of course, if you have only two variables, then it will be the x becomes a representation of x and y. If you have four variables involved in the function, then x will be x, y, z, w, and so on. So we're talking about multiple variables, so instead of spelling out all the variables, we're going to say, okay, the list of variables will be a vector, and we call it x, or being really an array of a variable. So x is x bar is an array of variables. All right. So so here's a quick example. All right. So suppose, let's stay with the hill. Suppose the height of a hill above sea level is given by z is the height, and z equal f of x and y, so we are looking at 1000 minus 0.01 x squared minus 0.02 y squared. By the way, what is the shape here? The question is, in what direction the elevation changing, is the elevation changing fastest? The fastest. And of course, what is the maximum rate of change at that point? I'm sorry, there is one more piece of information before I put the question mark. If you are standing, put you are as your. If you are at the point 60, 100, okay? And the second part, so this will be A, and B is what is the maximum rate of change at this point. The solution is not too complicated. The theorem tells you that the fastest rate of change will be the direction parallel to the gradient. So we need to find the gradient first. Okay? So, by the way, the quadratic surface is, somebody said, okay, somebody, I think, said it correctly. What is this? What is z equal 1000 minus 0.01 x? Elliptic paraboloid, yes. Because if you, let's say, y equals 0, you have the parabola z equals something in x squared. Likewise, you have z equals something in y squared. And then at the surface level, at the surface level for fixed value of z, you have the ellipse x in x squared and y squared. They have the same sign, so it's an ellipse. If they're different sign, then would give you a parabola. So this is the curve. The surface is elliptic paraboloid. Okay. Okay, so that was one comment, and by the way, it's negative, so it's open downwards. If it otherwise, huh? No, you know what I'm talking about. If you do a cross section, it will be, otherwise it won't be a hill, it will be a valley. So if it opens up, it will be a valley. If it opens down, it's a hill. And so what is the gradient? So del f of x, and I'll use this x bar, actually it's x bar, equals the derivative here will be negative 0.02 x in the I direction, then negative 0.04 y in the j direction. And if you want to evaluate it at the particular point 60 and 100, then what you have is it will be 2 times 60, so it will be negative 1.2 in the I direction and negative 4 in the j direction. Okay, So this is pretty much the direction, the fastest. We can write it like so: negative 1.2 comma 4, negative 4, and that would be the answer. Because the theorem that I gave you on the previous page state that the direction, the maximum rate of change occur at the direction parallel to the gradient. Okay. So what is the actual rate of change at this point? Then it would be the magnitude. So maximum rate of change or maximum slope of the hill in the direction negative 1.2 comma negative 4, okay, and the maximum rate of change itself equals the magnitude of the gradient at 60 and 100. So it's the square root of negative 1.2 squared plus negative 4 squared. So let's see, this will be 1.44 plus 16, 17.44, and this will be a number greater than 4, so it will be something like 4.18, I think. Something like that. But yeah, it looks like 418%, which is awfully steep.